Hey guys, today we're going to talk about things that are functions that are linear versus non-linear. So linear, let's talk about that first. Linear function is a line. A line will have some sort of rate of change, right? There's a function there, like we've been talking about these word problems. There's an initial value and that rate of change, and it's consistent every single time. Getting 2 cats every single day, or paying 40 cents for every MP3. There's a rate of change. So if we're looking at this graph here, I drew my x and y axis, and I've got a line. That's what it would look like. One of these 3 lines, not necessarily all 3, but a linear function literally looks like a straight line on a coordinate plane. Okay, pause the video, get that down. The next thing we look at is a table of values. Whoa. For a table of values, input-output table, I have my x values here. I have -1, 0, 1, and 2. For my y values, I have 2, 5, 8, and 11. And I'm looking for, is there a pattern? Is there a rate of change to determine whether it's linear or not? So I'm looking at my x's. I go from -1 to 0, 0 to 1, 1 to 2. Every time I'm adding 1. From 2 to 5 to 8 to 11, I'm adding 3 every time. So the rate of change is the same. That's what that says there, the same rate of change. It's 3 over 1. Rise over run, 3 over 1. So that's my slope, my rate of change. And then, not that we need to know it, but my initial value is 5 because that's when x is 0. My y-intercept is 5. But anyway, just determining whether this is a line, a linear function, because the rate of change is the same, it is. Okay, here I have equations. So I have y equals 7x, that's a linear function. Y equals 2x plus 3, that's also a linear function, or just y equaling x. All of those would turn into lines if we graphed them on a coordinate plane. Okay. Now, so those are examples I need you to be familiar with. Now, we're also going to talk about non-linear functions, i.e. not a line. There won't be a rate of change that's the same. So here's my coordinate plane. I have my x and y axis, so I drew a curve here. That's not linear. I drew like a U-like thing here. That's not linear. I could also draw, this is one function. It's like a V. That's not linear. Linear functions stay straight the whole time. They don't bend and turn another direction. So you see anything that's like that, not a line, it's nonlinear. Okay, if we have this table of values here, and you're looking at my x values, I've got -1, 0, 1, and 2. And my y values, I have 0, 0, 2, and 6. Every time I am on the x values, I'm going up 1, plus 1, plus 1. And on my y values, I'm going plus 0, plus 2, plus 4. You see how they're changing? It's not the same rate of change. 0 over 1 does not equal 2 over 1, does not equal 4 over 1. So that makes it not linear. So if you're looking at a table of values and you see a different rate of change, it's not linear. Lastly, some equations that are not linear. Y equals 2x squared, y equals x cubed, y equals 1 over x, and y equals 2 to the x power. Remember, exponents, that's a power. So just start getting comfortable with non-linear and linear functions and the differences between them. We'll practice more.